everyone. Welcome to this episode of Eyes on Earth. Our podcast focuses on our ever-changing planet and on the people here at EROS and across the globe who use remote sensing to monitor and study the health of Earth. I'm your host, Steve Young. Landsat is a valuable tool that the USGS manages for the benefit of federal agencies across our nation that are involved in land use and land cover change issues. But Landsat's value is appreciated well beyond America's borders. Here's a good example of that. Brazil uses roughly 70% of the water consumed in the world today for its extensive irrigated agricultural needs. Nearly 20% of all the planet's rivers flow on Brazilian soil, and its herds of cattle, pigs, and poultry are among the largest in the world. 4 years ago, members of the Brazilian National Water Agency, or ANA, began working with staff from the USGS and EROS to learn how remote sensing can be used to map Brazil's irrigated agricultural lands and how it can help to monitor and measure water used to raise crops there too. Here to talk about that are Sergio Arimarayas and Thiago Fontenelle from ANA. Welcome.
Thanks for the invitation and the introduction about our agency.
Thanks, Stephen, for the invitation too.
Also joining us is Mac Friedrichs. Mac is a contractor to the USGS and a lead technical developer. He uses Google Earth Engine to support research physical scientist Gabriel Sinai's evapotranspiration project at EROS. Mac has worked extensively with Sergio and Thiago on how to use Sinai's Operational Simplified Surface Energy Balance product, or CBOP for short, to measure and monitor water use in Brazil. Good to have you, Mac.
Hey, Steve. Thanks for having me.
So, Sergio, talk about the role ANA plays in monitoring agricultural and other water uses in Brazil.
As you know, in Brazil, we have a National Water Resources Management System. And ANA, the Brazilian National Water Agency, is the institution responsible for coordinating this system. Better understanding the use of water irrigation for planning purposes to guide the decision-making process in Brazil is the technical basis of our partnership with the USGS and EROS team.
Brazil's semi-arid landscapes have faced a history of drought over the last 4, 5, 6 years. The metropolitan area of Sao Paulo and the federal district face water supply problems. Today, the south part of the country is experiencing water resource issues too. Sergio, are Brazil's problems strictly related to drought?
All these cases have the lack of rain in common. This hydrological aspect is not the only factor that explains the water crisis. The growth in water use, low institutional coordination, the lack of investments in water and sanitation. In most situations, the regions were already at the limit of the balance between water supply and water demand.
Mac, we should educate our listeners a little bit on how remote sensing can monitor and measure water consumption. The CBOP model uses remote sensing, weather and climate data to track water available and consumption based on evaporation from the soil and transpiration from plants. How is that helpful in Brazil?
Brazil is a large country, and they need remote sensing-based technology to improve their water use assessment and water management decisions, just like we do in the United States. And ET is a large part of that water budget. As the National Water Agency in Brazil, water accounting information and monitoring at various ranges and scales is a really important component of their work. And the CBOP model, ET data, fits that need and has enabled new kinds of reporting and decision-making that they can apply in many real-world applications.
I understand the Brazilians heard your group present to the USGS Water Census Group in Atlanta in 2016 and asked you to partner with them on ET modeling and mapping irrigation in Brazil. What specific assistance did they want?
Going into this, we knew that this was going to be a mutually beneficial partnership. They are incredibly talented experts already in hydrology and geospatial information. And so really the goals were centered around capacity building and remote sensing ET specifically. Within the USGS, we develop and operate what's called the Simplified Surface Energy Balance model, and that uses land surface temperature from satellites, both Landsat and MODIS, to quantify the amount of water used by the land surface at field levels up to regional and national scales. So sharing this type of information and working with the team in Brazil was aimed to facilitate robust modeling capabilities on their end, and it's led to expanded opportunities for collaboration in mapping irrigation and water use.
Thiago, can you tell me how working with the EROS team and using the CBOP model has been an asset to Brazil?
Yeah, I can say it's a successful partnership. Gabriel and USGS team helped us from the basics on energy balance and evapotranspiration physics to modeling the variables and tools that we have nowadays. So this way, it has been a full training for us because we are not exactly scientists or researchers. We are water experts implementing the national water policy. So the USGS support has been very valuable for us. Remote sensing is valuable in a big and diverse country as Brazil. Nowadays, once a Landsat or MODES image is available, we can estimate irrigated areas in the areas we monitor in Brazil. So this is amazing for us. It's a long way from we were some years ago.
Flooded rice is the biggest irrigated crop in Brazil, about 1.3 million hectares. There are 1.5 million acres of soybean, bean, corn, wheat, and cotton under 1.5 million hectares of center pivot irrigation. How has EROS helped you to monitor and map those areas? Thiago?
We developed the CBOP BR. It's, as we call the CBOP parameterized for Brazilian reality. And it has been applied to compare data from water rights to the actual values informed by users. But it has been also applied to identify irrigated areas, very useful for planning purposes.
Mac, how much training have you had to do to enable the use of CBOP and other tools by the Brazilians?
That was mainly centered around ET modeling with the CBOP model, but also introductions to cloud computing tools and technologies for advancing large-scale science computing capabilities and interconnectivity. And we were working largely within the globally accessible Google Earth Engine platform environment. Most of this was comprised of a series of technical exchanges, webinar discussions, and various collaborative workshops, both here in the US and also in Brazil. And recently, this type of work has expanded based on various shared goals and some engineering of web mapping applications for using these water science products.
Do you get a sense, Mac, that the training and tools are making a difference in Brazil?
Yeah, I think they're pleased with the outcomes so far, and they want to continue. They've also invested a lot with local agencies within their country, one of them named AgroSatellite, who has been very beneficial for expanding even more applications with cloud computing side of things. And also various universities, and including the Ministry of Ag, are taking advantage of our training and partnerships.
It sounds like other parts of the Brazilian public and private sectors are benefiting from this partnership between ANA and USGS EROS. Is that right, Thiago?
There are nowadays a bigger group working with CBOP than 5 years ago. And I think ANA helped in this process once we make all of our results and tools broadly available in the internet. So it helps other stakeholders in Brazil. And we also invited other institutions and stakeholders for the 2 trainings we had in Brazil with Gabriel's team and USGS. These also help spreading interest in evapotranspiration modeling in Brazil.
Sergio, is this work that you're doing getting noticed by the public and the media in your country?
That's an important question, yes. The communication work on our water use studies, especially in irrigation, has been done frequently. The results are very well received, both by the specialized sector and by society in general. And it's important because historically, our water resource management system has focused on the urban use, the water supply for the cities. We currently have almost 8 million hectares under irrigation, and this number can be 2x, 3x bigger. The potential is huge.
You would call this partnership then quite successful, Thiago?
This specific work with evapotranspiration wouldn't be possible without USGS support and training. So it's really amazing for us.
And Sergio, would you agree?
Well, definitely. We are very happy with the results achieved. The effort of development and implementation of the CBOP model for the Brazilian reality really has shown excellent results, especially when compared with field data and water balance estimates in our irrigated areas. And the availability of these results through the national territory fulfills the role of providing general access to the public and transparency. We are very happy with the results, but in a particular way with the friendship and also, of course, with the partnership.
If USGS EROS work in places like Brazil has been so successful, it would seem like we might be useful to people and agencies in other countries around the globe. Is that the case, Mac?
Yeah, so there are groups that use the CBOP product in places like Africa through the FuseNet program, the Famine and Early Warning Systems Network. And there are also students and researchers applying CBOP for local applications, as we've seen in some papers in China and India, including big projects such as global water accounting by researchers in the Netherlands.
As your team works with countries like Brazil and the others, what do you learn from those experiences that help you improve CBOP?
Yeah, so it's very much been learning experiences where we can learn where the model works well and where it doesn't. And a lot of it is tied to the quality of the input data sets in different countries and finding different sources of information to apply within the model. And we improve our work, and using those improved data sets, we can make better model assumptions and improve the parameters to handle regional differences in various hydroclimatic conditions.
We've been talking today to Sergio Arimarais and Thiago Fontenelle of the Brazilian National Water Agency about how their work with USGS and EROS helps them to better understand how water is being consumed in their country. Thanks for joining us.
Thank you. It was a pleasure.
Thank you.
We also appreciate the insights today from Mac Friedrichs, who works with research physical scientist Gabriel Sinai's evapotranspiration project at USGS EROS. Thanks for your participation, Mac.
Thanks again for having me.
We hope you come back for the next episode of Eyes on Earth. This podcast is a product of the U.S. Geological Survey, Department of the Interior. Thanks for joining us.